everyone. Here we have another past paper go through. Now please note, this is for the triple science content only. Okay, so this is paper 2 of 2022, but the triple science content only. All the other bits of this paper are part of the combined higher paper, so you need to go and watch the video for that to see the rest of it. This is only the triple content. Okay, I've said that a load of times. I await this flurry of messages asking me where the rest of it is. Anyway, right, it says titanium dioxide nanoparticles used in sunscreens. State one property of titanium dioxide that makes them suitable for sunscreens or sun cream. Well, it absorbs UV, doesn't it? Absorbs UV. Nice. One risk with nanoparticles. Well, they're quite new, okay? They're quite new. So the long-term effects, where's that L? Long-term effects not known. Not known. Lovely. Now, figure 1 shows the surface area to volume ratio of different diameters of spherical nanoparticles. So, basically, what happens as this gets bigger, okay, so as diameter increases, surface area to volume ratio decreases. Lovely. Right, what is the surface area volume ratio of a spherical nanoparticle with a diameter of 80? Okay, so you just need to work your way up. They're going up in quite a predictable fashion, aren't they? So should we do some counting? 60 would be 3 to 30, 70 would be 3 to 35, and 80 would be 3 to 40. Okay, it's just a little bit of counting and noticing the pattern there. Hopefully you counted it and noticed the pattern. Maybe you didn't. If you didn't, oh well, now you have. Now it says a different nanoparticle is cube shaped with a 60 nanometer side. Show the surface area volume ratio of this cube is 1 to 10. Okay, so first of all, we've got to calculate the surface area in total, which would be 60 times 60. That's one side. Okay, it's a cube. How many sides? 6. That equals 21,600. Okay, that's the surface area, and that's the surfaces. Then you calculate the volume. Now for the volume, it's 60 times 60 times 60. Okay, which equals 216,000. Okay, so then you could very simply say at that point, any kind of mathematical way of saying that, I would very simply say, look, 216,000 divided by 21,600 is 10. So shows a 1 to 10 ratio. Right, we now jump to question 4, because I'll remind you again, the other questions are on the higher paper. Go and watch that. Now it says the acid in figure 6 can be used in the test for carbonate ions. It's HNO3. Doesn't tell you the name, weirdly, because that's the next question. Should we do that now? HNO3 is nitric acid, isn't it? That's nitric acid. I'll stop trying to be joined up. It's not helping anyone. Now, the acid can be used in the test of carbonate ions. Explain using the name of the hazard symbol shown what safety precautions should be used. Well, first of all, that says it's corrosive. The acid is corrosive. So you need gloves and goggles. Okay. Now, state a property of glass that makes it a suitable material to make the container for an acid. Now, when we talk about group 0, we talk about that special word starting with I, which is inert, which means it's completely unreactive. That's a good word to use there. A teacher conducts a flame test to identify the metal ions in some unknown solids. Okay, so you dip it in hydrochloric acid, you put it in the solid, you hold it in a Bunsen burner flame. Hold it above a Bunsen burner flame. What can we do to make step 3 better? Well, basically, you put the wire at the tip of the cone. Okay, so if we'll remember, I'll sketch it down here. We've got your Bunsen burner flame. you always end up with like, you've got a big flame and then you've got another little flame there. Now that point there, that's the hottest part. Okay, the tip of the cone, which is the hottest part. Oh look, flame test colors. You've got to be able to identify these. Lovely. I gave you that sheet, I told you to learn it. There we go. P is red, that makes it lithium. If you put strontium, fine. Q is lilac, that's potassium. K, that's potassium. R is copper. Okay, because it's blue-green. There we go, easy peasy. Right, a flame photometer was used to analyze samples of a solution of metal ions. Each sample was treated with 5 centimeters cubed dilute hydrochloric acid. 1 decimeter cubed of the acid contained 219 grams of hydrogen chloride. Calculate the mass of the hydrogen chloride in the acid used to test 20 samples. Okay, so first of all, we've got to say we've got 20 samples. Okay, we are going to times that by, okay, 5, which is, obviously we're going to divide that by 1,000 to turn into decimeters, okay, and we're going to times that then by 219, okay, so basically you've got your number of samples there, you've got 5 divided by 1,000 to turn this into decimeters cubed, and then you're timesing that by 219, and that will give you 221.9 grams. Okay, nice. Okay, so that's the end of that one. There is a slide, I think. Oh no, there's not. Is there? Hang on. Which question's next? Let's have a little look. See here. We jump to question 8. I'll remind you, 5 and 6 and 7 are on the combined paper. So look at that. I've said it 3 times now. I await the emails. It says a precipitate is produced when an alkaline solution is added to a solution containing some metal ions. Which of these is evidence of a precipitate being formed? Well, is it fizzing? No, that's evidence of a gas being formed. Is it a solid forming in the solution? Yeah, that's pretty much what a precipitate is. Okay, is it the solution turns purple? I'd say that's probably more of an idea that it's an alkaline. Or is the solution gets hot? No, that's an indication that it's an exothermic reaction. A solid is formed. That's the precipitate. You are given 2 solutions, one containing copper ions, calcium ions, sorry, that's calcium, and the other containing aluminium ions. Okay, and you need to devise a plan, basically make an experiment to suggest which solution is which. Okay, so essentially, right, we're going to use sodium hydroxide. You're going to use sodium hydroxide. Okay, now they will both give a white precipitate. They will both give a white precipitate for both. Okay, but Al3 plus, the white precipitate, will dissolve in excess alkali. Excess alkali. Okay, so for Al3 plus aluminium ions, the white precipitate will dissolve in excess alkali. However, for the Ca2 plus ions, the white precipitate does not dissolve in excess alkali. Great. Now, B says a scientist carries out tests on V and a solution of V. Here are the test results shown in figure 11. So, the appearance of V is a white solid. Does it conduct electricity? The solid does not conduct electricity. Does the solution conduct electricity? The solution conducts electricity. Okay, if you heat it to 400 degrees C, the solid does not melt. If you add sodium hydroxide to solution V and warm, a pungent gas, W, is released, which turns damp litmus paper blue. Okay, a And if you add dilute nitric acid followed by drops of silver nitrate, acidified silver nitrate solution, you get a cream precipitate. Right, first of all, let's start to talk about all these things. It's a white solid, okay? So, what does that tell us about the metal? Okay, it's not a transition metal. It's transition metal, because transition metal compounds are coloured. Okay, what kind of bonding is present? Ionic bonding is quite clearly present. Okay, and we can say ionic bonding is present because it's soluble in water and conducts electricity in solution. Okay, now we've then got to identify what it is. I'm going to do it over here. So essentially, when you add sodium hydroxide solution and warm, W is made. Okay, now W, okay, is an alkaline gas, and it's pungent. That means it's ammonia. Okay, because that's our gas test for ammonia. Okay, when we do that, we know we've got ammonia. Now X. We've got X, so we've got a cream precipitate. Cream precipitate with our acidified silver nitrate, and therefore we've got bromide ions. Okay. Now, what can we therefore do? How can we identify this? Well, we've got ammonia produced. We've got bromide ions tested for. So, therefore, V, got to identify V. We've identified W and X. Got to identify V. It does say, work out what V is. It's ammonium. Remember, when it's in an ionic compound, it's ammonium, not ammonia. It's ammonium bromide. That's what V is. Lovely. Okay, where are we now? Which question? Question 10. Okay, no question 9. I'll remind you, question 9 is on the combined paper. Go watch the video for that. We have question 10. Look, it's a molecule. Give the name of the hydrocarbon shown in figure 14. Meth, eth, prop, bute. So it's butene. Okay, but can we have a different butene? Can there be more than one butene? Basically, do we have an isomer? Yes, that double bond could go here. It could instead be there. So what we've therefore got is butene. Okay. Now it says complete the balanced equation to show the reaction of hydrocarbon Z with bromine. Now what will essentially happen is, remember, that'll break. You'll get a single bond and you'll get a bromine. So you're going to add Br2, easy peasy, and then you will very simply get C4H8, and you're going to add the Br2, so just Br2. It then says, draw the repeating unit of the addition polymer formed when hydrocarbon Z undergoes polymerization. So I would, as I told you before, make the double bond directly. So there's our double bond, right? So that's going to break. Our double bond's going to break. Okay, in fact, let me sketch up here. So we've got our double bond, okay, and on each one of these, we've got a CH3. Okay, this is, in the nice way to draw it, this is our monomer. Now, our polymer, on the other hand, essentially isn't going to have said double bond. H and an N. Now, the mark scheme actually helpfully says ignore the brackets and N, it just wants this, but I'm going to draw it anyway just because I'm not happy with that. I don't think it necessarily shows that it's joined. So there we go. That's what's going to happen. Remember, draw the double bond in the middle, work around it, will make your life easier. Now, B says, arrangement is an alcohol. Okay, give the name of the carbon-containing product formed when the alcohol undergoes dehydration. Okay, and that would be propene. Okay, because if you dehydrate that, what is dehydration? What do you take away? You take away H2O. If you take away that, you take away that, take away that, okay, stick a double bond in, jobs are good. You would make propene. Now, does it need to be a number in protein? No, because the double bond can only really go in one place, so you don't need a number. Right, give the formula of the functional group of the product form when the alcohol forms oxidation, undergoes oxidation. So when you oxidize an alcohol, you end up with a carboxylic acid. Lovely. Nice. Next, it says, a student wants to investigate the amount of energy released when 1 gram of an alcohol is burned. They set up that apparatus. Explain why it's not suitable for the experiment. Okay, now you've got a burner which is going to burn. You're going to get a flame. You've got a polystyrene cup. What's going to happen if you put a polystyrene cup in a flame? Okay, the polystyrene cup will melt. It will melt. Then you'll make a mess. You will. And you'll say, I've made a mess. My cup's got a hole in it. Really? Anyway, now it says, some alcohols, okay, can react with carboxylic acids, form polyesters. Lovely, just done that. Give the formula of the other product. So, when an alcohol reacts with the carboxylic acid to form a polyester, a small molecule is given up. Now, this molecule is H2O. Okay, because if we remember, jot it over here, we've got our CH3. I'll sum that down if that's okay. Got this going on. We've then got our alcohol. I'm just going to do methanol if that's all right with you. So we've got this going on, remembering that these three, that's actually a debatable thing, but that's A level. These three go away, and you end up with water, and you form your ester. Beautiful. Now, it says, draw the structure of one molecule of the alcohol used to produce the polyester. Now, if, like here, we use an alcohol, will a polymer be formed? No, because obviously that reaction is going to happen, and that'll be the end of it. You won't get a long chain. What you need for this, okay, is you need an alcohol group on each end. You need a diol. Now, here is your alcohol. Here's your alcohol chunk. Okay, we've got 3 carbons. You're going to have an OH. You're going to have another OH. And then you're going to fill in the hydrogens. Don't not fill in the hydrogens. Fill in the hydrogens. I know, you know they're there. I know they're there. The examiner knows they're there. But draw them anyway, because otherwise you'll get it wrong. Okay, simple as that. Right, now I think I'm right. That is it. That is all the triple science content of the 2022 triple science paper. Everything else is combined science content. Look in the combined science video for that. It's all in there. Watch that again if you haven't already, or already have, and then come back and watch this one again. Watch them as much as you can. Listen to them when you're asleep. I don't know, whatever works for you. Anyway, thank you very much. I'll see you very soon for another really enjoyable video.